Hello everyone, this is Drivo here, and today we're going to build an Angular project and make it ready for production using Angular NX. This is going to be an intermediate level workshop, and we're going to learn many new things throughout this course. Quickly before we start, I should introduce myself. I'm actually working at Vermeer as a full stack web developer. I usually use Angular as the front-end framework, and that is why we're here. Now, the first thing we should know is what is NX? Well, it is a framework that helps us develop, test, build, and scale multiple Angular applications using modern tools like Jest, Cypress, NGRX, and much more. So it basically takes all of Angular framework's core and the CLI and provides a much more modern experience with better linting, testing, faster CLI, etc. Okay, now let's talk about the more important stuff, which is why we should use NX and what can we gain from it. So let's put it this way. When we're dealing with Angular, the Angular CLI generates our Angular code. NX, on the other hand, sits on top of the Angular CLI, and when it generates a project, an Angular project, it does it with some additional functionalities. More importantly, it actually follows the concept of a mono repo, meaning multiple projects can actually be organized and grouped together in whatever way we find to be most logically consistent, so it allows us to generate more than one application and organize it in a way that you can start to share code across those applications. Now, what is really interesting is that not only you can run an Angular application from NX, but you can run a React app using this monorepo pattern, so you can have an Angular and React app sitting side by side next to each other. Now, in my case, I'm going to use this feature to have both Angular and Node projects together. But before we proceed with NX, let's talk a bit about a very important topic, which is data modeling. Let's say you start a new project, whatever it is, and you don't know where to begin. The first thing you need to do is to understand the data model for the domain that you're working in. This way, it becomes very easy for you to know what the rest of the application is going to look like. For example, let's say we have a user model, which will have first name, last name, and an active boolean. So when we look at this model, we have a very good idea of what the UI is going to look like for this particular model. For instance, we would have two input fields for the first name and last name, and a radio button for the active attribute. Not only that, for the REST API, we know that we're going to have an endpoint for /users, and a users/id, which is a get method that returns a single user by ID, and a delete endpoint which follows the same concept, and so on and so forth. The point is, if you understand the data model, you're going to understand the shape of your application from the UI all the way down to the API. So you can stack your features side by side correctly. Moreover, if you're using NGRX, you're going to know what your actions, reduces, effects, and selectors are going to look like. Now, here's a situation that most front-end developers encountered in their projects, especially when they're working with a team. There's always this hard dependency on the backend team to produce the API that you're going to consume. So the front-end team is done and the back-end team is not, which is going to be a blocker. If you have an agreement on the data model, you can go ahead and mock out the API because the model is the same, and you're able to finish your feature, and when the API is ready, you can switch back and use that with no trouble. So let us see how this is done in practice. So I'm going to generate an application completely from scratch and build it out. So how we do is from the command line, first make sure the Angular CLI is installed in your computer, and let's run npx create Nx Workspace, and then give our workspace a name, for example, Angular-production. So what this command does is actually install Nx tooling for you, and it gives you many options. You can choose many workspaces such as React, NestJS, etc. But what we're going for today is Angular plus Nest, which allows us to prepare a full stack application. So let's give the app a name, select our style sheet, which is Sass. For the NX Cloud, this is actually an optimization by NX for production, but we're not going to choose that option for now. Now, as you can see here, NX will parse all of this into one large command, and we'll start installing all the necessary packages. If you don't want to go through answering all these questions, you can simply run npx create Nx Workspace and concatenate it with -- and you precise the option that you want to add, for example, preset. Then equals and you choose your preset, which is in this case Angular-Nest. Now this way we already have an entire Angular Nest application ready to go. So let's go into the project directory and run npm start. Let's hop into the browser and we can see the home page of Nx being displayed with a message equal to null. Now this message is actually being retrieved from the Nest API, which in our case it doesn't exist. What is happening here is the Angular application is trying to reach out to the Nest API, but doesn't seem to find it. Well, it is actually very simple. All we did here is run the front-end application by running ng-serve, but we didn't actually run our Nest application. So let's see how we can actually adjust our package.json file in order to run more than one application. You can streamline multiple commands at the same time to make it easier. Let's shut down our Angular application and let's install a package called concurrently, which will allow us to run multiple servers at the same time. Now, let's go to our root directory and open up the package.json file. And let's tweak this so we can run the Angular application in parallel with the Nest application. So what we'll do here is create some custom commands. One of them is going to be called serve::API, which is equal to nx run API :serve. This will run the Nest API. And the second one is serve::web, which is equal to ng-serve. The last command is serve::all, which is equal to concurrently, and we put each command declared previously between a backslash and double quotes. So now let's save this and go back into our command line and execute npm run serve::all. Alright, so now from a single command, we are able to run the client and server into separate tabs. And yeah, as you can see here, we have our message displayed in our Angular application, which is returned to us from the localhost 3333/API/hello. You can find this endpoint in the controller file of the Nest application. Okay, so let's talk a bit about our file structure that exists within this application, just to lay the foundation of how things are going to be organized. So, as you can see, Nx separates the apps from the libs. So think of something that the user interacts with or something to be consumed in the service area that goes in the apps directory. So we have our Songify app here, where we find all our default Angular code. It is as if you ran ng-new in the Angular CLI. Alongside with that, we notice that we have the end-to-end Songify, so not only do you get an Angular application, but you also get Cypress integrated into this monorepo, which is very important. And because we have our API, we'll find the Nest application right there. Now for the libs directory, it is where we'll find our shareable code across our multiple applications. So we can start adding libraries via Nx libs. So I'm going to add Angular material and ngrx. First, let's install our packages. We'll start by typing npx nx add at angular/material. It should ask us if we want to proceed. We say yes, obviously, and for the rest of prompts, we can just hit enter to choose the default values. For ngrx, let's run npx nx add at ngrx/store. Alright, now we can generate some libs by running npx nx generate lib. Let's call this one material -- style equals scss. Let's also generate another lib called core-state, which handles the state of our application. More on that later. And last, a lib called core-data. Let's set the writing for these two libs in case we need them later. So now if we go back to our code, we notice that we have a new lib called core-data. Now this is usually used to communicate with the server, so we'll define our data models and use this library for server communication. So now that our libs are set up, let's go ahead and make our data model. So let's head to API-interfaces TypeScript file, which is under the libs directory. We can already see our message model that the default Nest application is using. This model file allows us to share the data model between the front end and back end, or another application. So you can use these interfaces, especially when you're dealing with TypeScript. We can make a base entity, so export interface base entity, and within it we have the ID, which is string or null. So pretty much everything that comes through this is going to have an ID. Now we add our model named song, which extends base entity, and inside it we will have title and description of type string. Now let's go ahead and generate a service in the call data lib. So run npx nx generate service, which is going to be under services/songs, and we'll call it song service -- project call data. And there you go. Now you can see that in the call data we have set up a service for our data model. So let's talk a bit about the config files. So in our angular.json, in the projects property, here we can find all our apps/libs that we have in our workspace. And if we add a lib or app, it will be pushed to this array. Now in the nx.json, we also will find the list of our projects. In addition to that, you'll be able to understand the relation between these projects. For instance, the Songify end-to-end is naturally dependent on the Songify project. Now, if we go down to the ts.config.base, we'll find in the path properties some aliases. Now, this allows us to essentially import things, and instead of having to type the long paths of the libs, we can use these aliases. And this is why, for example, if we go to our component.typescript, we already know that it's using the Nest API. We can see that it's using the message data model from API-interfaces, and it's doing that using the alias of the path. Now, let's make use of our created material lib. Now, you probably already guessed that this is going to be used for the Angular material library that we installed earlier. Now, if you have worked with Angular material before, or even PrimeNG, you already know that it has a lot of modules, so instead of having to import everything across different components, we can create a module, which we already did, and inside it, we import everything and export it at the same time, so it's like a bridge for all the components of your application. So I already prepared a module.typescript file that does this for me. I actually found this in Stack Overflow, so shout out to the guy who made this. I'll provide the link from Stack Overflow down below. I actually removed the imports array since this module is only for exporting modules, so we can just leave the exports array that allows us to use all these modules in our apps. Now all we have to do is head to the app.module.typescript and import the material module using the alias that we discussed earlier. And let's do the same thing for the rest of the libs and add them to the imports array. Let's also add the default routing to our app module. So we run npx nx generate module app-routing --flat -m equals app.module.typescript. Okay, so everything is set up. Let's go ahead and build our components. So let's run npx nx generate component songs-m app module.typescript -- style equals scss. And we do the same thing for the home component, and for songs list and songs details, we're going to generate them under the songs component directory. Now we can see that in our app, we have our home component, and our songs component, which is the container component inside it, will have the other two components. Now, before we start, I'm going to use a lot of templates and styles from the material library. So we're not going to write all the code in this video because that would take us very long. So you can take all the templates with me in parallel from my GitHub repo, and we're going to go through every one of them together. So to be able to understand the structure and workflow of our app, I'm going to start by the most specific components and then go up to their parents until we reach our app component, which routes between both home and songs components. So we obviously have the songs list component, which will be a material card. So it has a title, and the content is going to be a material list item that loops through the songs that we declare in our TypeScript file. So the songs object is going to be retrieved from the parent component, which in our case, we have two parent components calling this songs list component. But either way, we just declare it as an input property, and the type is song array imported from the API-interfaces. So inside the list item, we're going to have a span of the song title and also a button, which will only be shown if the property read only is equal to false. So this property is also going to be retrieved from a parent component, specifically the home component. So we declare it in the TypeScript as an input property and initialize it to false. Now for the click events, every time we select an item from the list, we're going to emit the song object to the parent component. The same case if we click on the delete button. So let's go ahead and declare the output properties in our TypeScript file. Okay, as I said, we're going to have two parents calling the songs list component. The first one is the songs component, so the selector is going to have the input directive, and we pass to it the songs object array, which is going to be initialized in the ng-on-init lifehook. So we set the object to the mock songs declared at the top. Now, if you face this kind of compilation error saying that the property has no initializer, this is actually caused by the strict class initialization that is applied to TypeScript files. To fix this, all you have to do is head to the tsconfig.json of the Songify app and remove both compiler and Angular compiler options, because we don't actually need them. Now for the output listeners, we're going to listen on both selected and deleted event emitters. And the first method is going to set the selected song property to the emitted object from the songs list child. It is noted that this selected song is initially set to the empty song object declared at the top. For the other listener, we're going to do the same thing, except this time we're going to remove the emitted song object from our songs list using the built-in filter function. And of course, set the selected song to the empty song. Now, the other child is going to be the songs details component, which is also a material card having the title edit song if we have a song passed to us from the parent. So in the TypeScript, the song is going to be an input property of setSong function that sets both the current song property and the song title used for string interpolation. For the rest of the card, we're going to have a form with submit event, which will emit the modified or created song by the saved output property declared in the TypeScript file. The inputs are going to be mapped to the current song with ng model, and we obviously have two buttons. One is of type submit and the other is cancel, which will reset the form and trigger the cancelled event emitter. Let's not forget to import the forms module in the app.module.typescript in order for Angular to recognize the ng model directive. Now, if we go back to the songs component to see the output listeners of the songs details, we can see that the saved listener will call the save song function, which will have two cases. If the song emitted has an ID, we are in the edit case, so we will just call the update song function, which will map all the songs array, look for the desired song having the ID, and assign it to the emitted song object. After that, we obviously reset the form details, meaning we set the selected song to an empty song. Now, in the case of creating, we have a new instance of song with no ID, so we're going to call the create song function, which will generate an ID randomly by this getRandomID function, and for the rest of the attributes, we're going to get them from the emitted object. And last, for the cancelled listener, we're going to call the reset song details, which will simply set the selected song to the empty object. This will automatically clear out the input property passed to the details component, which will eventually clear out the form. Now we move on to the next parent of the songs list component, which is the home component. So we pass to the input directive the songs object, which is initialized in the TypeScript file to the same values as the mock songs object. We also pass the read-only input property because this time we want the songs list to have the read-only property set to true. So we won't be able to see the delete button in each item, meaning we only have the list of the songs without modification. All that's left for us now is to construct the app component, which will have a material toolbar at the top with two buttons. The first one is going to toggle the side navigation, and the second one is just for the account profile. Now for the side nav, we'll have the logo icon which takes us to the root path, meaning the home component, and then we have two navigation items. Let's add the logo in the assets folder. Again, you can find this picture in my GitHub repo. So let's remove this hello API call because we don't need it anymore. And let's declare a links array containing information about each nav item link. So each time we have a path and a title and also an icon for the list item. Now in the template, all we do is loop through this array and call the router link each time with the specific link. And for the icon, we output the link icon. For the container section, we'll have a router outlet, which will load either the home component or the songs component, depending on the route that we are on. Below that, we'll have a list of banners, which is going to be a static set of pictures. So we declare an index in the TypeScript that will allow us to render multiple images, and each time the path of the image is going to change its index. So we would have banner1.jpg, then banner2.jpg, and so on. And of course, let's go ahead and put the banners images in the assets folder. And yeah, that's our whole components workflow. Now let's set the routing. So let's head to the app routing module.typescript and declare our paths array. So we declare the constant routes, which will have three paths. The first one is home, so path is empty and will render the home component. The second one is /songs, which will render the songs component. Now any other path is just going to redirect us to the empty path declared previously, so it will render the home component. Let's import the router module in order to set it to the root routing, having the routes declared at the top, and then export it right away. Let's delete the app component styling provided by the CLI, and let's finish this off by applying the global styles to all of our components. I'm going to take the styles from my GitHub repo and paste it in the styles.scss file. Let's add this last class to the root selector in the index.html in order to apply the material typography. And there you go. Let's do npm run start. And this is our template. So you can see that if we choose the home navigation, we only have our songs list component being displayed with the list of songs from the mock array. And if we choose the songs path, we will have both songs list and songs details components next to each other, with the ability to select every song and modify it in this form. And you can even delete it, which will remove it from the array. Now, up to this point, we've managed to create a basic Angular application using input and output properties, event binding, interpolation, etc. So if you want to continue with me from this point, you can go ahead and download the source code from the branch that I'm going to commit my code into, so you don't have to write all the boilerplate code. You just have to understand the workflow of the components, which I think is very simple. So all you have to do is go to the link in the description, click on the code button and download the zip file. And you have all the code and you're all set. Now, you might have noticed that our list of songs is static, declared in the TypeScript file, which is not really practical in a real application because all of the modification will disappear as soon as you change the route or reload the component. So what we're going to see in the upcoming section is how to make this a bit more dynamic. For that, we're going to use json-server. And this is going to allow us to remove the hard-coded data within our components. So let's go back to the command line and run npm install json-server. Let's make a folder under the root directory. We'll call it server. And inside it, we make a file named db.json. So inside this file, let's go ahead and define our songs object, just like the one we defined in our components. Now let's update our package.json file by adding one more command. We're going to name it serve::json, and the value is going to be json-server server/db.json. Let's now head to the terminal again and execute npm run serve::json and open localhost 3000, and you can see that our songs endpoint is there, and when we access it, you're going to see the list that we declared in the db.json file. And we can even access a single song by adding slash and the ID of the song. So this is actually the fastest way to get up and running with the RESTful API. Now, let's go ahead and consume this. So let's head to the songs.service.typescript in the core data lib. In the constructor, we're going to inject the HTTP client. At the same time, we need to add the HTTP client module to the imports array of this lib. So let's head to the core data module.typescript and add it. Now we can import the HTTP client from Angular common HTTP, and we can start declaring our RESTful methods. We'll start off with a method called all, which will return all the songs. So return this.http.get, and we give the method a generic type of song array. And the URL is going to be a constant that we declare at the top. We call it endpoint, which has a value of localhost 3000/songs. Now the find by ID method is going to be the same concept, except the type is going to be a single song. And for the URL, we're going to add /ID at the end, which is the ID provided in the method parameter. For the create method, we're going to call /songs as a post method and provide the body, which is the song object passed in as a parameter. The update is going to be almost the same, but instead of calling /songs as a post method, we're going to call it as a put method. And we concatenate it with /song_id, so it will update the specific song having the ID passed in as a parameter. Let's add the delete method, which pretty much calls the delete endpoint /song/id of the specific song. Okay, so this is great. This is the usual stuff that every Angular developer should know. But what happens when you have another application other than the Songify app in your workspace and you want to use the service? So now we are actually going to see how to pull this off thanks to the lib feature. So let's head to the terminal and generate another Angular application into the code. So we run ng generate app client, for example, -- style equals SCSS. And let's not set routing for this app to keep it simple. So -- routing equals false. You'll see that it's generating a client application and a client end-to-end application. So we can run npx nx run client, serve -- port 4300 to prevent us from running into port conflict. Because remember, we have the Songify app running in the default port, which is 4200. We can see that our new client app is up and running from our workspace. Let's close it for now and hop back to our code, and let's add a new command in the package.json file. Just like the other ones, we call it serve, client, which is going to be nx run client, serve -- port 4300. And let's run this command, and we obviously get the same result. Okay, so let's open our client app and let's clean it. So we remove the default templating and styling provided by the CLI. In the HTML file, let's type some random stuff. So now what we want to do is use the service that we declared in our core data lib in this client app. So let's inject the songs service in the constructor. Now here, it might not find the service as it's not actually imported in the core data module. So let's head to the index.typescript file of the lib, where you'll find all the exports that you might need elsewhere, and add the export of the service. Now head back to the app module of the client app, and let's add the core data module to the imports array. Now you can see that we can import the service from the lib using the alias, but we get a compilation error, which is fine. We don't have to worry about this because this happens sometimes with the Angular CLI when we modify the modules file. So just run the app again and you're going to be fine. Let's declare a variable called songs $. The $, is a naming convention, meaning this variable is actually an observable, and this is of type song array. And as you can see here, we get the no initializer error. So let's go remove the strict properties in the tsconfig file, just like we did in the Songify app. Now let's implement the onInit live hook, and inside the ng onInit function, let's initialize the observable, which is filled in from the all method in the songs service. Now all we have to do is display the songs list in the HTML template. So let's make a p tag, and with string interpolation, we're going to pipe the observable, so async pipe because it's asynchronous, meaning we don't get this list right away. And let's also pipe the observable to the JSON pipe to display the whole list as it is in the JSON server. Let's make sure that both the client server and the JSON server are both running, and let's check our browser. And there you go, we can see that we have our list that we get from our lib and specifically from the JSON server. Let's also not forget to use this service in our Songify app. So let's head to the home.component.typescript and replace the mock songs with the observable just like we did in the client app. Let's do the same thing for the songs component. So we add another variable holding the observable and we use it as the value of the input directive in the template file. Now obviously the CRUD operations that we do here are all applied to the static array that exists. So this won't have any effect anymore because we are using our song service, but we will fix this later on. Now if we open localhost 4200, which is the Songify app, we can see in the home page that we still get our songs, and same thing if we go to the songs tab. So you can see here that we have two separate applications in this mono repo that are both using the same service, which is the song service. So you can notice this kind of abstraction from your application's components, meaning you don't have any specific information about each component in the service located in the core data lib. That way you reuse its feature across your applications with no trouble. Okay. Let's try another thing that is very common in large projects. Let's say you want to use a component across multiple applications. For example, we have this material toolbar which is currently present in our Songify application and we want to use it in our client application. So how do we proceed in doing so? Well, you might have guessed, all we need to do is create this toolbar as a lib in order to use it in our apps. So let's go to the terminal and run npx nx generate lib ui-toolbar style equals scss. Now let's generate the toolbar component inside this lib. So we run npx nx generate component. Let's put it inside a folder called toolbar, and we give the component the same name as the folder project equal ui-toolbar style equals scss. So now what we're going to do is within our code, we need to extract the toolbar tag from our app component present in the Songify app and paste it inside the toolbar component. And then from here, we are going to change this side nav toggle to an output. Now, you might wonder why we are doing this. Well, this toolbar is actually not related to any of our apps. So if we leave this click event to trigger the material side nav toggle, it will get confused because it doesn't have a side nav alongside with it. So the solution for this is to make an output that will emit this event to the parent components, which in our case are going to be both app components of Songify and client. And there we can listen on this event and fire the side nav toggle from there. Now here, since we are using the toolbar tag provided by material, we need to import the material module to this lib in order for the component to recognize it. Let's also export the toolbar component in order for it to be used by our apps. And I think the lib is ready. All you have to do now is head to the app component of the Songify app, remove the material toolbar, and replace it with the selector of the lib component. Let's also add the output listener that will trigger the sidenav.toggle of material side navigation. Let's obviously not forget to add the UI toolbar module to our app module. Let's also head to the client app and do the same thing. This time, we don't have to actually listen on the side nav emitter because we don't have a side nav in the client app at the moment. But anyway, we head to the app module of this app and add the toolbar module. Let's also add the material styles that we use in our main app and also the material fonts in the index.html, because in this app we didn't actually install material like we did in the other app. That is why we are adding it manually. And there you go. if we head to our client app, we can see that the toolbar is there. And also if we head to the Songify app, we can still see the toolbar working as well as it is triggering the side nav toggle. So you can see that we managed to use a component across multiple applications. This is very useful in enterprise applications where you could use multiple apps and you want all of them to use the same kind of templates, styles, etc. So this allows you to do so without the need to write the same code again in each application. Let's commit our code to a new branch. Again, I'll post the branches link down below if you want to continue with me from this point. So all you have to do is just download it from the GitHub page. Okay, so what I'm going to do now is integrate Nest into the mix. So let's talk about it for a second for anyone who is not familiar with this framework. So we already saw how to mock an API with json-server, but you would never actually use json-server to do anything real. It's just a fake REST API and a placeholder until you have a real server in place. Now, Nest, on the other hand, is an out-of-the-box application architecture. It is highly testable, scalable, loosely coupled, and maintainable. And the most important part is that it uses TypeScript. So it's a reactive framework, meaning we can have RxJS. It manages dependency injections, so you can see already that this is almost Angular. So if you're comfortable with Angular, you're going to know how to work with Nest. So here's an example of a controller in NestJS. Seems familiar? Well, here's also a service in Nest, even a module. Here we have the decorator at module instead of ng module. One more thing. With Nest, you have the ability to add Swagger, authentication with passport, GraphQL support, socket IO, etc. So, without further ado, let's hop into the code and let's generate some stuff. Alright, so from the command line, let's install a package called mapped types of NestJS, which is an addition to the type system of TypeScript that allows us to create new types from existing ones and using methods like object.freeze to prevent us from modifying properties of an object. Now, let's generate the Nest API for our data model. So we run npx nx generate at nestjs/schematics resource, which is the architecture of NestJS API. We will call the module songs --type rest to choose the RESTful methods. You can also choose GraphQL if you want, and we add --CRUD true, and we generate this under our API app. So --source root apps/API/src. So let's see what this does. In our API app, we have a songs folder, and within it we have our module, and we have a controller which contains all the endpoints. We have the get, post, etc., all the REST methods which routes the verbs to these particular functions, which if you look in your service is doing some logic. So in a few seconds I was able to generate a full working CRUD API using the schematics inside Nx, which is very powerful. Let's hop into our API app module and let's import the songs module that we just created. After that, let's execute npm run serve all, and we see in the console, specifically the routes explorer, our songs route. This means that the NestJS is mapping through the songs API that we just generated. Now, if we go to our Songify app, obviously here we are returning the list of songs from our JSON server, not from our Nest API. But if we go to localhost 3333, which is the Nest API, we navigate to the endpoint/API/songs, we can see that it returns us this string saying that this action returns the list of songs, which is the response of the method findAll that the controller calls, which is located in the service file. So what we're going to try now is forget about our JSON server completely. So let's shut it down. Now on the songs service of our call data lib, we are going to change this endpoint. So instead of it pointing to the JSON server, we're now going to point to the Nest API. So we change the port and we add /API/songs. Now, since we don't have any data that we're pulling from our API, it's actually returning a string in the service. Let's change this so we declare an array of type song. So again, here you can see that I'm using the same data model on the backend as well as the front end. So let's define our songs in here. Now in the find all service of the backend, let's return that array and let's see what happens on our Songify app. So as you can see here, we are not getting the list of songs in our application. So something is wrong. Let's check the console and we can see that we get a communication error, specifically the cause policy error. So the backend is having some trouble to communicate with the front-end server. We can fix this by simply going to the main.typescript of the API app and we enable the cross-origin resource sharing. Now we go back to our app and there you go. We can see our songs list and everything seems to be working fine. Now, before we continue, I just want to point out one thing. Sometimes people get confused as to why we are using a service in the lib and a service in the Nest API. Well, the service in the lib is just a front-end service that just points to the backend controller. So in that controller, you could simply return everything that you need. But it is always better to separate the routing of the views done by the controller from the logic that we're going to do, whether it's returning something from the database or doing some operations. It's always good to keep all that stuff in the service area of the backend server. Okay, so what we're going to do now is work on the rest of the CRUD operations. Before we begin, I'm going to install an additional package called UUID that will allow us to generate random IDs that we're going to use for our newly created song objects. Anyway, we start with the find1 method, which will simply return a single song having the ID passed as a parameter. So we use the find method that takes the arrow function, returning a boolean. Now here, since our ID type is string, not a number, let's modify the parameter to type string. Now in the create function, we're simply going to push to the songs array the song object passed as a parameter from our HTTP request and assign an ID to it from the UUID library, which we import at the top, and then return that object to the controller. Now for the update and remove, we're going to use the same functions that we used in our songs components. So we map the songs array and modify the specific one in the update, and we use the filter function to filter out the song that we want to delete. So now we go back to the controller and we change the signature of the functions, because here we are not going to use the data transfer object, just to keep it simple. Let's remove the plus signs from the other function parameters and let's replace this patch decorator by put method that we import from the NestJS. Now the CRUD API is ready and all that's left for us to do is go to our Songify app and replace the static CRUD operations in the songs component by the calls to the API through our middleman, which is the core data lib service. We already treated the find all method, so let's start with the delete song method. So basically what we're going to do here is simply call the delete method and subscribe to it, and now in the arrow function we're just going to reassign our songs observable to the updated value of the songs list in our backend service. So we just call the find all method again, and for the update and create song we're going to do the same thing, except we change the method that we call in each time. Let's head to our Songify app and see if our CRUD API is working. So you can see that if we modify a song, it will instantly get updated on all our components. And even if we reload the page, we can still see the changes, and same thing if we delete or create a new song. Now we arrive at the last part of the Nest API section. This is my favorite part, by the way. So what we're going to do is install Swagger. So we run npm install at nestjs/swagger at 4 and also Swagger UI Express. Once this is done, we head to our main.typescript file of our backend application and we're going to type some code. So let's declare a new method. We call it configure swagger, which takes the app as a parameter, and then inside the callback function we're going to add options, which contains the title, description and version of the API, and then we build it. And let's finish this off by creating the document by the Swagger module and setting it up as the doc API for our backend application. Let's import both the doc document builder and Swagger module from NestJS/Swagger. Now let's apply this method to our app. So in the bootstrap method, we just call the configure Swagger and we pass the app to it. And let's run API:serve to start our backend server. And there you go. We have our API doc. We can access all of our REST endpoints that we worked on. So now you pretty much understand how to build APIs, which when you're building production applications, you are going to need to consume an API faster than the backend team can produce it. So you take that pressure off the backend team when they're probably overloaded. So we basically arrive at the main goal, which is removing that dependency from the backend team, as long as you have consensus on the data model that you're working with. Let's commit our code as always, so you guys are able to pull the branch that contains the most recent changes that we've been working on. This has been a long journey, and we have covered many topics such as learning basic Nx commands, generating multiple apps using libraries like Angular Material, sharing them across our apps, also sharing components with their workflow, inputs and outputs, services, mocking APIs with json-server, and NestJS. But we are only halfway done. We still have a lot to discover, such as reactive Angular and state management, facades, NGRX, testing, building and deploying on the cloud, etc. So if you enjoyed this part of the session, make sure you leave your feedback down below in the comment section and subscribe for more videos to come.